In this video, we're going to be doing our moments and distributed loads, and I'll also be teaching you as well how you can verify your answers to make sure that you feel confident in whatever that you're calculating. So normally we know you have your moment. Your moment would be equals to your force by distance. Then how does that look like? We know your force can be given in kilonewton or your newton, but at most you have your newton, then you're going to multiply by the distance, which is your m. So that's basically your moment. So your moment can either be calculated in your clockwise direction, or they can be calculated in your anti-clockwise direction. So each and every time you are about to begin with your calculation, you will decide if you are going to use clockwise as positive or you are going to use anti-clockwise as positive. Then you do your calculations. So let's suppose we have an example that's simple, or an example that looks like this. You have your A this side, you have your B this side, and the distance between here to there, you have your 4 meter. In between here, you have your 20 Newton. So I just want us to start with the simple ones, going to the harder ones as we go forth with the video. So as we know, this would be in the middle. It means this side we can say we have 2 meter, this side we have 2, but it's not always in the middle. They can give it to you somewhere. You just have to carefully look at the distance. And then here, let's just say they give you your AY, then this side you have your BY. So if we're about to interpret what we've written here in terms of this, we will say, okay, as I've said, you first have to choose the choice of direction. So we're going to say, we'll say let clockwise be positive. Then how are you going to calculate? You're going to say, I want to calculate my BY. So if I want to calculate my BY, I'm going to take my sum of moments around A. So what are you going to have? You're going to have sum of moment at A. You're going to have this 20 Newton, which is acting at that side. We have the force multiplied by the distance. The force, you have that 20 Newton. It's going in a clockwise direction. Remember, it's moving like this. So it's going to be 20. The distance in between it's your 2 meter. Plus, then we consider this force also. It's going in which direction? It's going in this direction, which is your anti-clockwise. So we're going to say, since we said our clockwise is positive and this one is moving in anti-clockwise, then we're going to introduce a negative sign. We have our BY multiplied by, what's the distance between this one and this point? We have 4 meter in between. So you're going to say you have 4, then this would be equal to 0. Then you have your 40 minus your 4 BY is equals to 0. Then you do the math, your BY would be equals to your 40 divided by 4. This would be your 10 Newton. Then you do the same to calculate your AY. In order to calculate your AY, you're going to take your moment around B. So you'll say sum of moment around B. Then what are you going to have? You have this AY which is going to move like this, which is your clockwise. So you will say you have what? You have your AY multiplied by the distance 4, which is the distance between there to there, plus what do you have? You have this 20 Newton in between, so it's moving in this direction. You're going to consider this distance 2, but it's moving in anti-clockwise. You have that minus 20 by 2, then this is equals to 0. You have 4ay minus 40 is equals to 0. Therefore, you see also with this 1, which is your ay, you are going to get your 10 Newton. Then now, how do I verify my answers? So you verify your answers by checking that, okay, we know that some of the forces that are going down should be equals to some of the forces that are going up. So that would mean this thing, it's balanced. So what are the forces that are going down? The force that is going down is this one, which is 20 Newton. So I have my 20 Newton. Then which ones are the forces going up? I have my ay and by. What are the values? You have your 10 plus your 10, 10 Newton plus your 10 Newton. Then you have 20 Newton being equals to 20 Newton. Then that means this whole thing it's balanced. You see? So now suppose that this is going to change, that they introduce what we call the pins, if you see things like this at the corner. So if they are introduced the pins, how is it going to look like? So if they introduce the pins, you're going to have a diagram that looks like this. They tell you that they have pins here, then they have pins here, and they don't actually give you in this form, but they still write it like this. Here you have your 20 Newton, here you have your 2 meter, you have your 2 meter, then they tell you here it's your A, then here you have your B. So first things first that you have to do, you make sure that you draw your free body diagram. Then you're gonna come and say you have a diagram that looks like this, but what does this 2 pins do? These 2 pins, they are trying to hold this plank in together so that it doesn't move in the y direction and also in the x direction. So it's holding this one in this direction, and it's also going to be holding this one in that direction so that it doesn't move at all. So you will have your bx, then you will have your by, then here you have your ay, then this side you have your ax, then here you're going to be having your 20 Newton. Then here you still have your 2 meter this side, and you have your 2 meter this side. Then now you're still going to calculate some of the moments around A and also some of the moments around B in order to find these values. But now you see, when you're going to calculate them, these ones are not going to be useful, your AX and your BX. Why are they not useful? It's because they're acting within this line, and we said, what's the formula for a moment? We said our moment is equals to our force by the distance. And if we have no distance, it means now we are going to be having force multiplied by 0, which is why these ones are not going to be considered. So suppose now we were about to take some of the moments around A. You see this one is just acting along this line here, but when you get around here, you actually have a force and also a distance, which is that 2 meter. So now, okay, let's say they change one part and tell you, okay, here we have a roller, this side we have a pin. How does a roller look like? A roller, you will see it kind of look like a skateboard like this. So now you have to draw your new free body diagram. How is that going to look like? You will have a free body diagram that looks like this. You have that 2 meter, you have that 2 meter here, we've already done it. You're going to have your AX, and here you're going to have your AX, I meant to say here, here you have your AY. So in this part, this pin, it's actually holding it together in your x-axis and your y-axis, there isn't any movement. But when you come to this side, you can see that within the x-axis, it's going to have a movement. So if it has a movement, it means it's not rigid within that point. We can't say we will have a bx acting this side, because it is moving because of these wheels that you see. So hence we will only say that it is being kept together in your by direction. But now you won't be having that bx. See, so always remember that when you're having a situation that looks like this, the bx is not going to be included because this thing is moving. Then here you still have that 20 Newton. Then you still do the same calculation. You take the sum of your moments around those points. Then now your last case would be when they've given you 2 rollers like those. If you're given 2 rollers like those, it means at your both sides you're going to have something that looks like this. You have your 20 Newton, which is here. You still have that 2 meter. Here you're only going to have your by. Then this side you only have your ay. You see how we were able to go back to this original one, because at point A and point B, this plank can only be held in the y direction, but in the x-axis you see that it's going to be having a movement. Hence I can't put my ax and bx, because if it was a pin, it was actually going to be pushing it like this to make sure that it's in place. But since there isn't any, because of this movement of this, we are going to do it like this. See, you see how all those changes, they reverted back to this simple one that we had in the beginning. Okay, so now we are advancing. We're getting to the distributed loads and moving up. So now let's just say you have a situation where, how can I put this on? Okay, you still have your, in this instance, they're just giving you your arrows. You have your ay, this side you have your by, but they've actually given you your distributed load across the plank that you have here. Then what do they tell you? They tell you that the distance between here to there, it's actually 4 meters. Then they give you the height for this one, that it's going to be how much. They tell you that it's 30 Newton per meter. Then you come and say, what is this thing? You can see this thing, it looks sort of like a square, but it's a little bit longer. You'll ask yourself, what is the area of that? The area of that is your length times breadth. Then you'll say, okay, what's my length? My length is this, is your longer side. You have your 4 meter multiplied by the breadth is this thickness. Then you have your 30 Newton per meter. Then you will see now, what do you have? You have this meter cancels this meter. Then you're only left with your 4 multiplied by your 30 Newton, and this gives you how much? This is going to give you your 120 Newton. Then now this 120 Newton is this load that is going to be acting within this one. But if it is for a shape that looks like this, we are going to put it exactly at the center, meaning now our new free body diagram is going to look like this. We have our by, this side we have our ay. So we're going to check that, okay, we have 4 underneath, then half of 4 is going to be approximately 2 meter, and exactly in the middle, that's where we're going to be putting that load of ours, which is 120. Then we have 120 Newton here. Then now you can come and calculate some of your forces around A and some of your forces around B to find your AY and BY. And after you found them, remember you still use that formula to check if they are balancing. Some of the forces that are going down must be equal to some of the forces that are going up. So just to make sure you've done the correct calculation. So now let's just say, for instance, they don't give you one which looks like a square. Like now they give you a problem that looks like this. You have that AY and you have this side, you have that BY. Remember, I'm just using these pins, I'm not pins, these arrows, because they're simpler to draw, but you can actually be given that pin and roller. You'll still need to do it the same way that I've explained. So now they give you something that looks like a triangle. Then they tell you that the distance between here to there is 6 meters. They tell you the distance is 6 meters. Then that would be your distributed load. Within that, then they tell you to calculate the reaction. Then remember, they would have given you the height for this triangle. Then they're going to tell you that, okay, what do you have? They might give you something like your 30 Newton per meter. So now the first step that you have to do is to ask yourself, what is the area of this one, or your triangle? We know the areas have base times your height. So you have your half base times height. Which one is your base? Your base is 6 meters. Then you're going to say you have half of base, which is your 6 meter, times your height. Your height is your 30 Newton per meter. Then what happens? You will say you have half of 6, which is going to be 3 meter multiplied by 30 Newton over meter. Then you can see that this one is going to cancel this one. Then you're going to be left with what? You're going to be left with your 90 Newton. But now the question comes, where are we going to place that 90 Newton? Remember, this one is not a square, so we can't just put it exactly at 3 meters. In this one, we are going to do it in 2 methods. So we have the short side and we also have the long side. Remember, with these arrows, or this method that I'm explaining now, I'm basically trying to pin out the distance where we're going to put this 90 Newton. So if I'm using this method, which I will just say it's the short side, then this one we can just say it's the long side. They each have a different formula. So your short side, you'll always use what? For your short side, you will say you have your 2/3 multiplied by your base. Then for your long side, you have your 1/3 multiplied by your base. So 1/3 with the base, I meant to say, is the 6. So with this one, you have your 2/3 multiplied by that 6. This side you have your 1/3 multiplied by the base, which is your 6. Then for this method, it's going to give you how much? With this one, it's going to give you exactly at 4 meters. Then with this one, it's going to give you exactly at 2 meters. So it means if you were having a ruler, so you would notice that, okay, I would estimate that approximately about here, this side would be 4 meters, then here would be 2 meters. So if I was measuring using this long side formula, I will know, okay, from this side to there, I'm going to measure my 2 meters. Then it means now that that 90 Newton, which is here, the distributed load, it's going to be acting somewhere here. So how am I going to draw it on a free body diagram? So I'm going to have something like this. Then here I have that 4 meter, this side I have that 2 meter. Then here I have that AY, this side I have my BY. I said if I used this formula, then I would measure 2 meter from this side going that side. Then I would have what? Then I would have that 90. I would have that 90 Newton there. So you have that 90 Newton there. But if I used my 2/3, I'm going to measure 4 meters starting from this side going there. Then you still put that 90 Newton. Then you see, now you can be able to do your AY and your BY calculation. So yeah, we're still advancing to another ones. So now you get to an instance where you're being asked something like this. Okay, let's just say you still have a plank that looks like this. Then you have your AY, and this side you have your BY. Then let's just say somewhere along here you have your 20 Newton. Then this side I can just call it 2 meter. Then the long side I can even just still use your 4 meter. Then now they've introduced a moment, or if you see something that is moving like this, we call this one a moment. How would a moment look like? A moment, then they said this moment, it's what? It's your 10 Newton multiplied by meter. So one thing to note, if they've given you a moment, is that this moment you see here, it actually acts within all this plank. So meaning you can move it and put it here, you can move it and put it anywhere within this plank. So even with your calculation, you're still going to include it as it is, depending on your calculation. So just to do it one calculation and show you how it's going to be. So let's just say we were taking some of the moments at A. So first things first, also, if you're given a moment that is going in clockwise, the wisest thing to do is to say, let your clockwise be positive. You see? Then now you know this one, you're going to take it as it is. You're going to say, okay, we're taking moments around A. We have this one which is going in your clockwise. We have 20 multiplied by 2, then plus what? This, we're going to just say it's 10, because remember, this is a moment. It's actually worked out, because the formula we have, moment is equals to your force times your distance. And even here we're still calculating the moment. You see, if you are taking it, because like I've seen people who take 4, now they end up multiplying by 2 again. You see, now you're working something else. So you're actually supposed to just take it like this. Then you go to your BY and ask yourself, okay, this one is going in anti-clockwise. It means I'm gonna have my minus BY by 6. Then this would be equals to 0. Then now here you're going to have your 40 plus 10 minus 6 BY is equals to 0. You have your 50 minus 6 BY is equals to 0. Therefore, your BY would be your 60, your 50, I meant to say, divided by 6. This will give you your 8.33 Newton. So that's for BY. So if we say we take some of the moment at B, what are we going to have? Remember our choice of direction, we still have clockwise as positive. We're going to say at B, we have our AY, we will have minus AY by 6 plus into, it won't be minus, I made a mistake. This is clockwise, so it's positive. Plus we have 20 secting this side, it's going to be minus 20 by 4, then we have plus 10. Remember, this one we are not just taking it as, we're just pretending or taking it as if like it's acting along all this plank, and it's already worked out for you, so you don't have to stress about that one. So you have your 6ay minus your 80 plus your 10 equals to 0. You have your 6ay minus 70 is equals to 0. Therefore, your ay would be your 70 divided by 6 gives you how much? This will give you your 11.67 Newton. And if now you can add and say, okay, if I'm going to do my confirmation, I have some of my forces that are going down must be equals to some of my forces that are going up. The ones that are going down, you have which one? You only have your 20 Newton. The ones going up, it's your 8.33 plus your 11.67 Newton. Then your 20 Newton equals to your 20 Newton. Then that means this thing, that's balanced. So now the last one, last but not least, you're going to have ones which looks like this. So they're going to give you a problem and say, okay, you still have a plank. Then they give you your ay. Then this side you can say, okay, they give you your by. Then somewhere in the middle they still give you your 20 Newton. But now what do they do? Within here they introduce a one that's like this, or it's acting at an angle. Then they say you have your 40 Newton. Then here they give you your 30 degrees, and they tell you to calculate your reactions. So normally with these ones, you are going to use your what? Your SOHCAHTOA. Your SOHCAHTOA, because you're going to be analyzing this triangle that you have. You have this triangle that you have, this side, you will say you have your 40. Because what we are trying to establish is that we cannot work with a force that is at an angle, so we would rather take its components. So we're going to be having a force that's like this in your y-axis, and we also going to have a force that is like this in our x-axis. See, because I'm only drawing these arrows like this because here I've indicated that the pin is going, but if it was going there, then I was gonna change the direction. I was gonna change the direction for the red ones and say, okay, they are going up, and this one will also be going away. See, that's also one thing that you would note. Then now, how do we actually work this one into components? Because remember, here we have that 30 degrees. Then this side we know we have our x, this side we have our y. If we want to work out the components and say, okay, let's just say now we have to determine the x component of it, then we're gonna go to the y. For the x component, you see, okay, no, I think I've mixed them. Here we have our x, here we have our y. So if you want your x, you will say, okay, this angle, it's opposite to this one, then this one, it's our adjacent. You go and look at the formula that's with your adjacent. Which one is that one? You can see that you are having this one, which is your cos. Then if you're going to consider this side, it means you're going to say you have what? Cos of 30 degrees is equals to your adjacent over hypotenuse. You have your x over 40. Then it means your x would be equals to your 40 multiplied by your cos of 30 degrees. See, Then now if you want your y, which formula can you use? You look for the formula that starts with your opposite. It's definitely this one. Then you can say you have your sine of theta is equals to what? Where's your opposite? You have your y over your hypotenuse is your 40. Then your y, you will say you have what? You have your 40 multiplied by your sine of 30 degrees. So now how is your new free body diagram going to look like? Instead of having this, you're going to have a new free body diagram which looks like this. You have your 20 Newton, this side you have your AY. Then here, remember, we've worked out the components to be able to calculate it nicely. Remember, we are only working with straight forces like this one and this one. We are not working with forces like that. If you have forces like this one, you work out its components like we did. So we've calculated the component of that one going up, which gave us our 40 sine of 30. So I just like to write them in bracket so you know that this will still need to be multiplied by the distance. Then the one going this side, which is the x-axis, we have that 40 cos of 30 degrees. Then now we know if we are going to calculate some of the moment around A, this will definitely be going in your anti-clockwise direction. So that's like that. And another way that they would ask you is that, okay, let me just erase this so that I have enough space. You see the portion that you have here, they can give you a triangle that looks like this. You have your 20 Newton, here you have your AY, then this side you have your BY, then they still give you this one and say this is 40 Newton. But instead of giving you that angle that was 30 degrees, they write something, they write a small triangle like this one. Then they tell you that this side it's 4, then this one it's 3. Then if they give you something like this one, you can actually use this smaller triangle which you see here, which is like this. You have your 4 and your 3. You work out this angle, because basically this angle, this triangle represents this one that you see here, which is the bigger one for this one. You see? So if you can work out this angle here, basically you've worked this angle here. So with this one, your tan of theta, you can say you have your tan of theta is equals to what? Your opposite over adjacent, your 3 over 4. Then you find your theta, going to say arctan 3 over 4, then you will be able to have found this angle here. So that's one way they would ask this question. So lastly, it's when they are going to hit you with everything. So I've taught you everything with regards to the distribution and also the loads. So they can give you one example which includes everything. So they give you something like this, then they can say, okay, from here to here it's 4 meters. Then you can say from here to there it's 3 meters. Then they give you what? They give you a force here that's at 40 Newton. Then here they give you your 30 degrees. Remember here they will say you have your BY, here you have your AY. Then they actually don't even give you they just give you something that looks like this. They give you something that looks like this. Then they just show you that, okay, somewhere along here, remember from here to there it's your 4 meters, but here it's your 1 meter, then here it's your your 3 meter. Then this side it's 3 meter. It's 3 meter. Then between 3 meter they put that 20 Newton. Then you see how now they're trying to combine all the information that we've used, and now this is the distributed loads in between. Then you have those distributed loads. Then they ask you to calculate some of the moments. With this type of ones, you still have to do the same things that we did to make sure that you are end up with forces that look straight like this. This one, normally if you see shape like this, try to break it down into two. You can have this triangle and also the other part. You know, the area for this one is your half base times height. Then the area for this one, it's your length times breadth. So for this one, you're going to be having your distributed force exactly at your half of 3, which is going to be 1.5. Then for this one, you're going to be working with the short method or the long one method. Then you're going to put it on that right region. Then this one, you'll also work out its component, the one that is going in the y, and this one you'll also work the one that is going in the x. So since you can be able to find those, you're going to be having the one here, 1, 2, 3, 4 that are going to go up. Then underneath you will have your AY and BY. And remember also underneath, it's not always going to be like this. Your two forces are pointing up. And as I said, they can be changing. You can be having that fixed pin, or this side they can change and say we actually have a roller. You see how now they're trying to make this question looks difficult, but we have actually been building up from the starting point. We started with one that looks much simple, going to this ones which actually looks a little bit advanced. But if you apply everything that you've learned from the beginning, it means now you'll be able to do all these calculations. So if you found this video useful, you can also go and check some of the videos that are made in the playlist. I actually have a different types of playlist for different types of your modules or subjects, whatever you guys call it. So go and check those videos out.